Hello, guys, and hope you're doing okay. I just want to take you through the end of term exam, that is electrical installation and breakdown maintenance, that is for level 4. So, I just want to take you through the questions that were there, that is the section B. Then I'll also go make a tutorial of the section A. So, at least I just want to go through the questions and also guide you on how you can respond to the questions. So if I go to my first question, which was list any 4 tools used in breakdown maintenance. So this is a question that runs across a variety of units that you're studying, because in installations you have some tools you use for installation purposes. So those tools can be used, also can cut across when it comes to maintenance, because for you to perform a maintenance of an electrical installation, then you'll need first to have the tools for installation, then some a few additional tools for maintenance. So the tools, we have diagnostic tools. So an example for a diagnostic tool, you have the multimeter, oscilloscope, signal testing meter, infrared thermometers, ammeters, voltmeters, and testers. So if you look at a multimeter in an installation, you may require to perform some voltage drops across different variables, that is for an electrical installation. You can also use an oscilloscope. It's an instrument that is used to measure waves or signals. We have the signal testing meter. The signal testing meter is used in telecommunications, that is during the time of installation of satellites. That's when we use a signal testing meter to confirm the strength of the signal at that particular point we're required to install a satellite. Then you have infrared thermometers. Infrared thermometers, they can be used to measure temperatures. That is when you are dealing with machines. You have ammeters for measuring current flow in any circuit or a component. You have the voltmeters, so they can be required to measure voltage. Then testers. The tester is just to identify a live circuit from a dead circuit. Then you have the mechanical tools. Mechanical tools, these are tools that will be required when doing some installations. They are like an additional tool. You might require to fasten something, a nut, a bolt, to make it firm. So you'll require some mechanical tool, that is from the mechanical aspect. So a wrench is used to tighten things, bring them together. Screwdrivers using in driving screws, because when mounting sockets you discover that they have some the screws that are needed to be driven into the sockets for them to be mounted firmly on the wall. You have the pliers. The pliers used to holding is a holding tool. Then you have the hammer for driving. Driving in, it can be nails. You can be performing an installation surface wiring on a carton or a box. That is the surface wiring. Most of them are done inside conduits or by the use of those polyps, the polyp nails. Then you have the electrical tools such as side cutters. A side cutter, when you're terminating cables, you can use a side cutter. The crimping tools, that is for fiber optic, we use a crimping tool. Then you have the wire stripper. Wire stripper also, when you're terminating cables or making cable joints, you require a wire stripper. Then you have power tools. Power tools, you have the blowers. The blowers can be used to remove dust from particles. So when performing an installation or a maintenance, you might discover that some components can be too much dusty. So it will require you to at least use a blower to remove the dust. Then you have the cleaning solvents. An example of a cleaning solvent, we used the lubricating spray. Remember, there's a question I asked you about a lubricating spray. And I used an example of that electrician or ule fundi wa simu. When he's washing those components, the motherboard, there is a certain liquid he uses. So that liquid, it can be a liquid or in form of a powder or in form of a spray. That is what we call the cleaning solvent. So just an example. Then you have the safety tools. Safety tools also is a requirement because for you to perform any installation work or any type of work in the engineering field, you require to have some safety tools or safety equipment. So that is how you were supposed to list. For those who listed examples, you can get a mark. If you decide to list with the categories also, you can also get a mark. So whichever the case, whoever said a multimeter, oscilloscope, wrench, side cutter, hand drill, blowers, the PPEs, if you mentioned any, if you said a safety boot, you are required to get some marks. So that's how we answer the first question. Then we go to the next. Identify any 5 things to look for when conducting a visual inspection test. So during my period or during our session in class, we said a visual inspection is a type of test that is carried by the use of a naked eye or by the use of sight. That is, we have to look for faults, defects, or malfunctions onto a system or a component or a device or an installation. So that is what we call a visual inspection test. So the questions was revolving around 5 things to look at. So whatever you're responding should be something that is visible. So if you say current flow, you cannot be able to look at a current flowing inside a cable, but you can be able to see a cable that is faulty. So when asked such kind of question, then you have to look at something that can be physically seen. So first, you can say cracks, dents, or deformation of components. When I'm talking of a crack, when you look at a motherboard, there might be a crack. That crack can be easily seen by the eyes. Then you have the dents. The dents is a form of scratch. If something has scratched one of the components, there is that spot that is left behind. So it can be seen. Then you have deformation of components, especially a capacitor, or if you look at a capacitor, it might have swollen. Something that has swollen, it has taken a different shape from the normal shape of the capacitor. So it tells you that that component is faulty because it's not as per the required shape. Then you have missing, loose, or damaged screws, bolts, and fasteners. You can find that when you're performing some maintenance purposes, depending on the circuit or depending on the equipment you're doing, some of them might have been fastened or made fixed by the use of bolts. So if you find some missing bolts, then that is something that you can see by the physical eye. When you're doing the maintenance, you'll have to look for other bolts that you can require to replace there so that you can make it be tight. So that's also something that you can look. You can look for missing, loose, or damaged screws or bolts or fasteners. Then you have burn marks, discolorations, and overheating. Burn marks can be seen, something that has been burnt. There is a spot that is left behind, a blackish or a black spot. That black spot can tell you that this component was burnt, maybe as a result of over voltage or over current, which made the spot. Then you have exposed, frayed, or damaged wires that are damaged. It can be the cabling in terms of the surface. The surface might have a wrong, maybe the cables are detached. So it shows you that cable is damaged. Then you have signs of acing or sparking. Where there is a sign of sparking, you can be able to see some spots of sparks. So that is physically, it can be seen. Then loose connections or improper secured terminals. A loose connections from the recent practicals that we did, I showed you how a loose connection looks like. You might find that one cable, maybe the live cable is passing through a socket and the other cable is not passing through the socket. It has been left hanging. So those hanging cables that are left, those are called loose connections. Then you have dust accumulation, dirt or debris. So you might find that some components might have a lot of dust on their surfaces. So that's when you can use a blower or the cleaning agent or solvent to clean that part. So when you're asked about a question of visual inspection, know that these are tests that I'm conducting by the use of the physical eye. These are tests that I can conduct to an equipment, and while doing that, I must be able to see them physically. So that is what we call a visual inspection, because we are using sight as a sense. Then we go to the next. Briefly explain the following types of maintenance. We have routine maintenance, preventive maintenance. So in our previous class, we talked about the three types of maintenance, whereby we said the routine maintenance, it involves a regular and scheduled type of maintenance that is responsible for the upkeep of equipment, machine, or systems to ensure that they work efficiently. The tasks involved may include lubrication, inspecting, or replacement of minor components to prevent unexpected breakdowns. So when you are looking at routine is something that you do on a daily basis. And something that you do on a daily basis, it's based on a plan. You might set a plan. So like if you are a student, there are some things that you do on a daily basis. Waking up, maybe you have seen people doing morning routines, going to bed. So it's done at a particular period of time. So most of the times when you relate that to the breakdown maintenance aspect, you find that we're now talking about something that is on a regular basis, but that type of maintenance, it does not involve so many complex which are activities which are very difficult. You're just trying to look at, you're doing it on a regular basis, but in case of a fault, those faults might be not so major or severe. They're just minor faults. For example, they can just require a replacement of maybe a nut or a bolt. When something is not tight, you just go fix it, make it tight. If you're passing through an installation and you find the socket outlets, you have some loose connections, you make them fixed. If there is no bolt or screws, the sockets are hanging, you make sure that they are fixed on the wall. That is what we call a routine maintenance. Then we have the preventive maintenance. It's a type of maintenance that aims at performing at regular inspections and maintenance to a system with repairs at predetermined intervals. Its main goal is to prevent potential failures and breakdowns, thus extending the lifespan of an equipment. So preventive maintenance, this if you try to put it on a medical aspect, one as among the vaccines, or if you go to get a vaccine is a preventive measure. It's just that it's a type of maintenance internally, but they're trying to perform these tasks so that they can protect that equipment from further breakdowns. So for preventive maintenance, we are looking at increasing the lifespan of an equipment, and that it should be done at regular inspections by our regular intervals. So the basic aspect of that regular maintenance should be brought in all those three types of maintenance. Then its main aim is to prevent future failures or severe failures. Because if you look at from the architectural side, when a house is built and it's finished, let's say you're looking at story cases or story building and it's finished, you find that there are times as the house is being occupied by tenants, there will be times where there will be some cracks. So whatever they'll be doing, the architect will suggest it's not a suggestion, but it's required by the law that in every building that has some cracks, the cracks have to be put zinafungwa, zile clubs hizo cracks zinafungwa or zinazibwa. Sorry. So the aspect of you sealing those cracks, it shows that you're trying to prevent a severe breakdown, maybe the building collapsing. So that is a type of preventive maintenance. Then next we'll have to go to the last, which was the corrective maintenance. It's a type of maintenance that involves repairs or replacements which are performed on an equipment after failure, breakdown, or malfunction has occurred. Its aim is to restore the device or equipment back to its normal operation. It involves a series of troubleshooting techniques that will aid in fixing the device to its normal operation. So this also a corrective maintenance, I can say is the last line of resort when it comes to maintenance. because first we start with the preventive. We have the routine maintenance, then we have the preventive maintenance, then we come to the corrective maintenance. So for the routine, maintenance, we said they are done on a regular basis, and it's just a matter of maintaining a circuit or maintaining a component by making sure if it's dirty, you're cleaning it. If there are loose connections, we're trying to make them fixed. For preventive, we say that we are trying to seal the defects in order to prevent or protect the equipment from severe failures. Now for the corrective maintenance, that severe failure has occurred. Maybe there's a big failure that has occurred. So the repairs, we will have to do the repairs if the device it's able to be repaired, or if it's completely damaged, then we'll have to replace. And I said in my previous class that if you are identifying or if you are troubleshooting a circuit and you see that 85% of that circuit, all the components in that circuit are faulty, if it's a motherboard that is an electronic device, you'll have to replace it, because there is no any other way that you'll have to troubleshoot one component after the other if it's 85% of that device. If it's an installation, you've gone to a site, it's an installation that has been performed, and you discover that all the sockets are faulty, all the switches are faulty, the consumer control box is faulty, the lighting system and the socket or the cooker system is faulty, there's no way you'll be repairing that system, because 85% of that system is faulty. So what you'll be required to do is replace. If it's a socket, replace all the sockets with new sockets. Replace the consumer control box with a new consumer control box. If it's a socket outlet, replace all the socket outlets with a new socket outlet. So whatever you'll be doing, that is a corrective maintenance. You're trying to correct on the previously existing installation that was done maybe some years ago. So this type of maintenance, maybe mostly it's done to a machine that has been, or a device that has been existing for a very long period of time. You find that it has been used a couple of times, so it ends up getting weary, the wear and tear. So inaenda ikiisha na unapata the efficiency, in terms of efficiency, it's not working well. So whatever maintenance we'll be doing to that system is what we call the corrective maintenance. So if we come to the next question, which was during troubleshooting of electrical equipment, there are some of the safety tips to be observed. So these are some of the safety tips, and I went through in class. I said that before you perform any electrical installation, the first thing that you have to do is turn off the power. By turning off the power, you will be in a good position to prevent yourself from potential hazards. And you also, after turning off the power, you isolate the equipment or the place that you are using from the power source. If you are doing an electrical installation and you discover that you have gone to a certain site and the lighting system is faulty, but the socket system is okay, the first thing that you'll have to do, you'll have to turn off the power from the main switch. After turning the power from the main switch, since during your initial access of the system you discover that it was only the lighting system which was faulty, you'll have to isolate the lighting system from the consumer control box. Make it open circuited, and you can also leave a tag there and say that the lighting system is being worked on, so that you can enable the socket system to work. Even if you resume the light, the socket system will be working as you work on the lighting system. So that is how the maintenance is done in a company or in an industry. You cannot find that the whole manufacturing process has been stopped simply because there is a maintenance that is being carried out. No. First, those maintenance team will have to isolate, to turn off the power, isolate the place they are working for. If it's manufacturing or the processing department, all other department will still carry on with the activities as they do the maintenance to the department that is faulty. So if you're looking at that from that perspective, as a maintenance person, that is what you should have in mind. Then next you have to, of course, wear the appropriate personal protective equipment. These are the equipment that can be able to reduce the level of death or potential hazards from occurring that might have some adverse effects to you as the technicians. Then you have to verify if the circuit is de-energized with a multimeter. Yeah, this is also an essential place, because if you take an example of an electrical motherboard, it has some capacitors in it, some resistors, some inductors, and other components. So if you put off the power, we have some devices that they store power or energy inside them, like a capacitor stores some energy in it. So you have to make sure that you have to test using the multimeter to confirm that once you have turned off the power and you have isolated the system from the main source of power, also these components that you are trying to troubleshoot, they do not have some energy in it. Then next you have to ensure the work area is dry, well lit and spacious. The place that you're trying to perform the maintenance, you should be in a place that is well spacious, that has some free air circulation. It's well lit, you can be able to see each component one at a go. And of course, it's dry, because you're dealing with electrical components. You're talking of keeping it in a dry place to avoid the short circuits, the type of faults that can occur, and can at some point lead to some potential hazards. When we have used insulated tools rated for an electrical works, of course, if you are an electrical person, you have the knowledge of the types of faults that can occur in any electrical installation circuit. So whatever you're using, the tools, you make sure that they are well insulated, so that you can prevent your body to come into contact with a live conductor or a live circuit. Then stay aware of the surrounding. In the place that you're working for, you should be aware of that surrounding, because ignorance has no defense. That is just a phrase that we always use. If you are working in a boiler or in a machine, you must be aware of that surrounding that you're working in, such that you're aware of any danger that can occur. Because you might be working on a site or something, you might slip and fall down. If you are not aware of that place that you are going to fall was slippery, then you'll end up maybe die. Or you can be working in a place that has stagnant water. So you're not aware. Maybe there is a leakage somewhere. There was a leakage somewhere, and you are not aware that the water leaked into the place that you are doing your maintenance. So once you have finished your maintenance, you have troubleshooted the system, you return the power, you get electrocuted, because the water that was stagnant there while you're performing the maintenance, you did not clear it off. So this tells you that at least you have to be aware of the surroundings while you're performing the maintenance practice. Then you have follow manufacturer's guidelines when troubleshooting. I talked of the service manual during our previous class. We talked about what are some of the components that are found inside a service manual. And I told you that each component, each electrical gadget that is being imported or that is being used has to have a manual. The manual it's used as a guide. Whoever is going to troubleshoot that equipment, he has to go through the manual so that he can understand how the machine works, if it's a machine, and be able to troubleshoot that equipment. So I also, when it comes to installation, you have to draw the wiring diagram, because you're always told, draw the wiring diagram. Make sure you draw the wiring diagram. That wiring diagram is just a lesson that you're trying to input to you, that when you go to the field and you're given a task to perform an electrical installation, you'll have to draw a wiring diagram first. After drawing that wiring diagram, go perform the installation, and leave a copy of that wiring diagram to the engineer or to the owner of the house, such that in case you are not around and there is a fault, if another technician comes to visit the site or to visit that house in order to troubleshoot it, he can request the wiring diagram. He can go through the wiring diagram and be able to understand the type of installations that you did at that particular place. Same place that comes when it comes to machine. When a manufacturer imports, when we import a machine from outside, those technicians are not there to come and help us to install the machine. They will put a service manual inside it. When the machine reaches our country and is taken to an industry, the technicians of that local country can go through the manual, understand it, and be able to do the installation of that machine. So that is how essential it is. Always follow the manufacturer's guideline. If you're not aware of how to troubleshoot a component, you can request for a service manual. You can request from them, they give it to you and go through it, you can be able to troubleshoot it. I gave you of so many stories of how I found myself using the service manual to equipments that I was not able to troubleshoot at that particular time. But when I was given the service manual, I went through it and I saw how the instrument is to be installed, and I performed the task. So it makes your work very easy. Then after you have done all that, test all the equipment before re-energizing the component. That's where we always fail. A person will finish troubleshooting an equipment and immediately puts on the power. If you turn on the power, you might have done the installation wrongly. You might have done it in a poor way. So you end up also making the situation to become worse. So after you've finished, and if you go back to our notes in class, we talked about the procedure. That procedure, I said, it is among that procedure where I said, before you go to insert the power source, after troubleshooting the equipment, you have to test by the use of your testing instruments, by the use of your multimeter. That test that we always tell you during practicals: perform a continuity test, perform a polarity test, perform an insulation resistance test. Those three tests, we are trying to ascertain to you that before you now put in that power source, you make sure that those three tests are in line. If they are checked, then that is when you can be convinced that I can now take it from or tap it from the power source. So that is also how you can answer that. So questions of this kind, they are always called comprehension questions, because you are trying to look at the aspect of how well do you understand these troubleshooting techniques when you're in a different field. And I always told you that if you're looking at maintenance, don't look it from an installation side of view, because we can maintain an installation. We can also maintain an electrical component. The other times we talked of the iron box, the electrical iron box, and we talked of the heater, how to repair a heater and how to repair an electrical iron box. So if you look at those two components, they are not installations, they are electrical devices. So if you're trying to look at maintaining a circuit, you also try to look at how to maintain an electrical device. And after you look at that, you can also look at how to maintain a television. A television is also a device. So you're looking at it from the electronic sides, the device side, and also from the installation side. So on to the next question, which was outline 5 duties of an electrical maintenance person. This is also an application question, but we also went through it in class. So an electrical maintenance person, you look at, you have so many ways you can look at this question, because it applies in a various fields. In every field or in every place, there's always an electrical maintenance person, be it a hospital, a school, it can be an industry. So once you're answering these questions, you have to broaden your mind. Look for, you are trying to look for points. So it should not just be in one line. You are thinking it in one line of a school setup. Some of us, when you finish school, will be employed in different places. You can be employed in an industry, you can be employed in a hospital, you can be employed in a bank. Banks also have a maintenance persons for electrical in banks. So you have to look at what are some of the duties of this person based in a variety of fields, not just a single field. Looking at it from that perspective, we'll be able to gather more points that you can use to put into this question. So one of them, it was inspect electrical systems and equipment. Of course, that is his main purpose, to inspect. Always to make sure that all the equipments are in check, all the installations are in check, there is no short circuits or those other associated faults. Then we have diagnose and repair electrical issues. In case an electrical issue arises, this person should be able to diagnose by the use of the two tests, one which is the visual inspection and the other which is the use of electrical instruments. So you have two types of inspections that you can use and testing. Then you have perform routine preventive maintenance. So I have taken that point from the types of maintenance. So if you just say he is supposed to perform routine, corrective and preventive maintenance, that is a duty. Then you have repair malfunctioned electrical systems. Of course, once he passes through maybe a certain station and finds that there are defects in a certain electrical system, his main aim is to make sure that he repairs that system. You can take an example of maybe an industry. He is walking through the various workstations in an industry and finds out that maybe in one department, maybe the mechanical department, they are having some defects in maybe the circuit breaker is faulty. As an electrical maintenance person, you'll have to either repair that circuit breaker or replace it, because if you don't do it, then the working or the processing of that activity in that department is stopped. So that is also another purpose. Install new electrical tests for safety and efficiency. The company or industry might bring in some new devices, electrical devices. So since you're employed into that industry, they will not go ahead to go and import labor or import experts from the other outside world. They employed you for that purpose, so you'll have to go and install that new component into place. And there are so many ways, because you'll not be a single person. For most companies or most industries, the maintenance person is always a group of team. It's like a whole department. So if it's a new system that you are not well aware of, you can sit as a department or a group and try to discuss on how you can handle the system. So that's how you as a maintenance person, you are obliged to. Then you have upgraded electrical systems when needed. So you as a person, you can recommend, or you as a team, you can recommend that the systems that we are using, these electrical devices that we are using, they are so much out of date. Maybe they are so much analog. You can recommend to maybe the management and say, let us have a new digital system of electrical devices that can be able to help us solve some works within a short period of time and save time. So that's also another task. Then you have respond quickly and promptly to emergencies. You have always seen that if there's an emergency, maybe there's a power surge or the generator is not kicking up, the maintenance person will be the ones who are questioned. Why is it not picking up? So you as a person, that is an emergency, something that has happened abruptly without any expectation. So you as a team, you have to recollect yourself, go to that place or to the generator side, try to look at what is bringing the issue. So that is some of the duties of an electrical maintenance. And I've said questions like these, always think beyond just the school setup. Think it in a different angle, based on different careers, based on different occupations, based on different farms. So that's when you can be able to come up with points. So the main aim here is to come up at least with reasonable points. Then next we look at the 5 types of faults that can occur in an electrical installation. So these types of faults I already showed you during the last practical that we did, how a short circuit looks like. A short circuit looks like we look at the terminals. Maybe the live terminal comes into contact with the neutral terminal, the ground terminal. That is a short circuit. We have overloads. Overloads can be seen as a result of sparks maybe. So you might have connected a device that has a high rating than the source or the supply source. So it can cause some sparks. That is an overload. You have overloaded the source with a load that has a higher rating. Then you have earth faults. Earth fault can come as a result of ground faults. The ground wire. Open circuit. Open circuit can also be treated as a loose connection. Then you have ground faults, over voltages, circuit breaker failures, corrosions of equipment or materials, because these electro devices, some of them are made of iron, others can be made of copper. So depending on the reactivity series from the chemistry point of view, that corrosion can cause some faults. Then next we go to state three advantages and three disadvantages of breakdown maintenance. So as we always say, that for anything that has an advantage will always have a disadvantage. So this also question is an application question. It looks at, now that you have known the aspect of breakdown maintenance, what it entails, how to troubleshoot, how to test, how to inspect, what are some of the benefits of doing that, and at the same time, what are some of the drawbacks of not doing that or doing that at the same time. So one, it lowers the initial costs. Lowers the initial costs. Here we are looking at, if you maintain a circuit properly, let's say you are talking of an industry point of view, machines that are used or electrical devices that are used in machines or in industries, they are very expensive, and most of them, they are always important. But if you perform that regular maintenance to that machine, to those machines or devices, you'll find that it will lower the term or the number of times you are required to import a system, and thus saving the company's costs. Then you have simple to implement, no unnecessary interventions, then cost effective. The disadvantages, you have high repair costs. That is a disadvantage because if you look at, maybe if you're trying to troubleshoot an equipment or an electrical device that has fewer spare parts in town, you can find that maybe to get that spare part has to be shipped from abroad. And also, if you look at the cost of buying now the whole equipment, it's very expensive. So the repair cost can be very expensive because of maybe shipping the materials or the spare parts from outside the country. Maybe because the number of spare part dealers associated with that device are very few, and most of them do not have it. The reduced equipment lifespan, yeah, and that is of course, this aspect applies to vehicles. Someone has always asked that if you buy a vehicle and you take it to a mechanic that is not authorized, maybe especially those who stay in Gara or those just mechanics that are not authorized, and they open that, the moment they open that bonnet and start going through the engine, the lifespan of that machine is reduced. That is just a fact. So if there is a new machine and it is opened, and I always tell you from the last practical that we did, that if you are got in a situation whereby you are going to repair a circuit or going to repair a motherboard or you are going to repair an installation, and you find that, let's take an example of a board, a circuit board, a motherboard. You find that there has been some soldering which has been done to that motherboard. The first place of contact, once you are trying to troubleshoot, is that place where there is a replacement or a soldering. You might find that maybe the person who soldered that place so did not solder it correctly. So that is always your first point of contact. And if you look at even the mechanics, when they are trying to troubleshoot vehicles, if they open that bonnet and they find that there's a thing that was replaced, that is always their first point of contact, because you find that 90% of that fault is being contributed by the faulty part that was replaced initially. Yeah. Then we have safety hazard occurrences. You have seen these maintenance people when they are inside the machines. Maybe they might not have informed the people from other departments that there is a certain maintenance that being performed. Someone goes, puts on the light, someone gets electrocuted while performing a task. So safety hazard occurrences is also a disadvantage. So these are some of the application part. You just look at the time you're performing a maintenance procedure. What are some of the advantages to that activity you're doing? And at the same time, what are some of the disadvantages to that activity? Then next we go to define the following terms as used in maintenance. We have a service, a fault, diagnosis, and visual inspection. So these four terminologies, when we are introducing the unit, that is the electrical installation and breakdown maintenance, the first topic we defined these four words. And if you're talking about service, most of you are doing it incorrectly by defining a service based in business. We're not talking about service in terms of businesses, because a service in business is something that is intangible, something that we give in exchange for money. For example, is a banking. Banking is a service. Transport is a service. But if we come to maintenance, we are now talking about with respect to electrical devices or with respect to machines. So a service, you can say these are actions or steps that are taken to repair, restore, replace a faulty component of a system after failures occurred. So those activities that you are taking or actions that you are taking to replace, to repair any faulty components or device into a system or an installation, whatever you're doing, that is a service. You're trying to do some service. And also service can also include cleaning. Yeah, that's why if you go to this hao fundi, unasikianga wale fundi wa TV, fundi wa radio, fundi wa simu, if he opens, according to the Nairobi region, just opening that system without performing nothing inside it, he just opened, he will charge you 300 shillings for opening, which is also acceptable because he took some time opening it. So all those activities that you are performing, why it can be cleaning of the component, it can be opening, you are trying to replace, you are trying to solder a place that is faulty, you are trying to replace a component with a new component. All those activities and actions that you are doing is what we call a service to an electrical device or an electrical system. Then you have a fault. A fault here we are defining, this is the abnormal functioning of a system. So a fault refers to a malfunction of or defect or failure to a system that disrupts its normal functioning. And I told you in the previous class that if you have, there were different types of faults that we talked, that is the partial fault and the total fault. So we said the partial fault, the system is working, but not as per its expectations. So I said you might find that you are using a charger. The charger is rated 3.1 amperes, but when you use the multimeter, it is giving out 1.5 amperes, half of its rated capacity. So it means that even if you have your load, which is the phone, you are charging it, it will take a very long period of time for your phone to be full. So that charger has a fault, and that fault, it's not a total fault, it's a partial fault. The system is working, but not according to its 100 or to its expectation. When you had the total fault, which I said the system is completely faulty, all the components are not working. Yeah, then you have the mechanical fault, which was as a result of the internal circuitry of the component, which is not working. Then you have the diagnosis. Diagnosis here, I saw some people defining it with respect to medicine or the medical part. So the diagnosis from the medical part, we always talk of doctors. Once a doctor tries to ask you some questions, he's interviewing some questions and trying to get the cause of the disease that you are suffering, and administers the correct prescription. That is what we call a diagnosis. But here we are looking at the maintenance and electrical installation aspect. So you have to relate your words or statements with respect to the installation side. So you can say it's the process of identifying the cause of a failure or malfunction to a system by testing or using visual inspection. So that act if you're given a device, if it's a radio or it's a dryer or a grinder, someone from the village comes to you and say, my grinder is not working. So that process in which you're opening it, you're trying to identify what are some of the causes of it. You're using a multimeter to measure some components inside the grinder or inside the blower or inside any electrical device. And at the same time, you're trying to touch some few aspects there. You're trying to see if there is anything inside it that might have contributed to the fault. That entire process that you're doing is what we call a diagnosis. Then we have the last definition, which is the visual inspection, is the process of examining an equipment by the use of the naked eyes to identify any cause of damage or malfunction to a system. So the key word to this statement is the use of the naked eye, because it's visual. Something that is visual, you have to use a sense of sight. You have different senses, so you use the sense of sight to ascertain that there is a malfunction to a system. And I said that once you're doing the diagnosis, if you find out that you have exhausted the visual inspection, you have looked at the circuit, you're looking at the components, they are okay, according to your visual, according to your sight, or according to your eyes, everything is okay. Now the second aspect is you implement the use of the testing instruments. You try to test the instrument by the use of a multimeter, the ammeter, the voltmeter, and other aspect. If you look, or if I draw you back to the previous lesson that we learned about the steps of diagnosing or troubleshooting a component, and we did it also practically, you can be able to relate with what I'm saying. So otherwise, this was section B, and I just wanted to get you through some of the aspects of what we were doing and some of the responses which were not so much appealing in your end of term. So always, for maintenance, it's a very interesting unit which just requires you to most of the time to use application. And I said that breakdown maintenance goes hand in hand with the electrical installation. Whatever you're doing, try to relate and try to apply it, because here you're applying it in school, but after school you'll be now applying it in the field. Others, I hope this video helps you also in your revisions in the entire upcoming exams, and I wish you the best.